Hi guys, I'm Amit. Been working with Credit Karma for over 2 years now, and I love it there. It's a great company to work for. So I'm a senior build and release engineer. I'll be actually basically talking about how Dockerization has empowered our continuous integration and how we have changed the way we do CI at Credit Karma. So the next slide is pretty much the agenda. I'm going to deep dive into this. Like, first I'll be like, what is CI? And then what issues we had without the CI, without Docker, and then how Docker empowered our CI. And then I'll just quickly go over the key technologies, and then if you have any questions and answers. So the next slide tells, like, all right, what is CI and why do we need it? So as you see, like, clearly, continuous integration is a process where you can plan, code, and build, test, release, and it's happening continuously. The faster the results you get back from your coding, the better it is. There's the biggest advantage is being, your production is having code which is much more stable. It's neat. It's already passed your test. You don't want CI until unless you are this guy, So, the next slide goes about what issues we had when we were not Dockerized. So before I start that, I want to tell you guys a story. I want you to meet my friend Peter here. So he joins a company as a DevOps guy who is responsible for setting up Jenkins and CI/CD pipelines. So what he does is he actually configures a server, installs Jenkins on it, and starts building, pipelines. So the company starts growing, and then he gets his clients, and he's like, "Oh, this engineering manager one wants." She goes, "Can I get a build pipeline?" And he goes, "Yes, I'll set up you with some pipelines." And the company starts growing, and Meg joins, and Chris shows up, and then Mayor and Glenn. All they need is their build pipelines on the single server, a VM, which is Jenkins installed on that, right? Now, what Peter ends up with a huge one VM with Jenkins installed with all these projects on it. Like, it's complicated. He will start having issues like performance issues going forward, and that's not end of his problems. Like, every now and then the customer will show up and say, "You know what? I need you to upgrade my Java version on my Jenkins instance, say 1.8," and his pipeline works, but what happens is, as he upgrades this, he breaks the other guy's pipeline, right? So he's upset. So clearly, some of the issues with that approach was scalability. Like, this solution is not scalable. There are a bunch of dependencies issues, as was talked in the previous slide. Customizations are a nightmare. Like, you cannot customize your Jenkins instance when so many people depend on that one particular VM. Upgrade downtimes. If you want to upgrade your Jenkins instance, you just bring a downtime, and the whole company waits for you, saying, "All right, you will be up in like 2 hours, 3 hours," and if you're not up, everybody is looking for you, so you better be up. It's a challenge. And then access issues, like, who needs access to what? Oh, I need read-only access to this job. I want to deploy this stuff. Like, most of the engineering is like, "Oh, I want to install this plugin." So it's basically a nightmare. So, and then host machine dependencies. Like, when you have so much going on with your application, some team will come and they want to do a security patch, right? Now somebody applies a security patch, your underlying application fails, right? So that's one of the biggest issues. So what happens in that case to our Peter? Dude, he gives up, right? So gets up in the morning, next day says, "Oh, I got an idea. Maybe Docker can help me in this," right? So he goes to the office next day and he goes, "All right, I'm going to change the way things are right now, especially with this VM who has Jenkins installed on it. So what I'm going to do is I'm going to get rid of it. What I'll do is, instead, I will give each and every team their own Jenkins container." So this is a Jenkins container running as a Docker container. So what he's done is he's given each team their own container, and each team has their own application access level. Like, they own that application. Now they own their own Jenkins, right? And he sets up a internal registry. In our case, we have Artifactory. So what he does is he's pushing the base image to Artifactory, and the other teams are pulling that base image and they're customizing their own images, and they have their customized Jenkins image right there. So on top of it, he goes, "All right, let me get you something more." So what he does is he uses Terraform to actually codify their infrastructure. Now their infrastructure piece is also automated. So what it does is, they are all on AWS, and that whole infrastructure is codified using HashiCorp's Terraform, and with one click of a button, they own everything. So in the next slide, what I show is, what does it mean to a given engineering team member, right? So this is Meg. So everything is working for her, and then one day she shows to office, and things crash, right? Things will crash. So what she does is, no panic, but what she does is, she just runs this Terraform script. In our case, we run this script through a Jenkins job itself. You can have a CLI or GUI or whatever you want to, but it runs it. What it does is, it spins an AWS instance, and as part of provisioning on Terraform, it actually grabs the image for their team, a Jenkins image, from a registry into the EC2 instance, and they're up and running. That's how simple it is to recover. So what have we just achieved? She is now much more it's a self-service model. She has much more control on her own environment, both on the infrastructure level and the application level. She can actually upgrade on her own wish. She doesn't need to disrupt anybody else. It's not a nightmare, and it's easy to upgrade. And her environment can be as unique as possible, because it's a Docker container. End of the day, she can do whatever she wants to. She's got more power. She's owner of the application and the infrastructure. And yes, this is a much more scalable solution. Oh, remember that guy Peter who used to do all this? What he does these days? Parties. Because everything is self-service, right? But apart from that, he's writing tools. He's busy writing tools for his engineering teams, right? So some of the tools that we have here is, if you're part of Credit Karma Engineering, and if you want to spin a CI instance, we have a CI instance which can spin you a CI instance. So we have that level of automation. Monitoring and instrumentation. We take our monitoring and instrumentation very seriously. We have system level and service level KPIs defined. We have dashboards around Splunk. We use Datadog for our monitoring and alerting. We will know if there are, for example, there are 5 builds in consecutive failure. We know something is going wrong. So those are service level examples of service level KPIs that we do. Automation. Keep on innovating on the automation piece. We have fully automated Docker build pipelines at Credit Karma. So that's something we do all the times. And yes, we are focused on our roadmap. We know, we are always planning on what is ahead, what are our plans going forward. So what is Peter not doing these days, right? So he's not a single point of failure, right? I mean, every team owns their own CI, right? He's not a build or a deploy monkey, right? He doesn't do all that. He's not the guy who's just configuring jobs for people, pressing buttons. People can do that themselves. He's just writing tools, right? And he doesn't care about the underlying infrastructure issues. The infrastructure is all codified. It's on AWS. And then yes, he doesn't get to blame for things he's not responsible for. A build and release engineer can get blamed for build failures on what development broke, but in this case, we've outsourced everything to our engineering team. So that's one of the things. So how Docker changed things for us? Yes, it made the biggest thing that we've achieved is we've made everything as self-service to our engineering teams. It's much more scalable now. The ease of rollout and rollback. For us, rolling out is basically running another container, and rollback is getting back to a container from the last tag. So that's our rollout and rollback. It's very easy to implement, and there are no host dependencies. Some of the key technologies that we use is Docker as the backbone. We use Jenkins as our CI tool. Artifactory hosts our Docker images, and it's our repo for everything else than that as well. Splunk, we have dashboards, we have alerts, we have everything from into Splunk. And for right now, we are on Bitbucket. We have future plans to replace this stuff, but that's coming in future. And we use Terraform to codify our infrastructure. So that's the underlying key technologies that we work on, and that's pretty much it. Any questions? Yes.
Is this only for developers to develop? Because when you are on a production or a pre-production environment, you need common infrastructure, job definitions, history of builds, rollbacks? How do you manage that?
So yeah, we have stuff in our co-op and we have stuff in our prod environment, but what flows from our co-op, right? So what we build in co-op is through our CI system is what is getting deployed in prod. So when we build the stuff, the artifact gets pushed to our artifactory environment, and that is the only stuff that gets replicated in prod, and that's the one deployed. So there is if you don't pass the test, well, while you're building an artifact and it doesn't pass certain level of tests, you cannot deploy that. In fact, no human is allowed to actually even merge our stuff to our stable branches or master branches.
So even within developers, let's say I add a feature which needs a flag. Now everyone on the team, the build would fail unless they have the flag. The job definition need to be common, even though we are separate developers, right? So you need to store the job definition so all the developers can share the job definition.
I can talk to you offline, but I don't know if I'm getting the context of the question here, so can take it offline after this. Yeah.
You said you're using Terraform within Jenkins to build the environment then?
So we are using Terraform as a code automation for the infrastructure piece of it, not within Jenkins, but Terraform can be built used to
Each team is running a Terraform applied.
Well, we have again automation around it too. We have a Jenkins instance which does this step behind the scenes. So if you are a developer and you have stuff, you just need to press a button on Jenkins. We have that stuff also codified. It's behind the Jenkins job.
Do you use state storage in S3?
Depends on different teams. Some teams do, some teams don't. It's different for every team.
So I'm wondering whether you get VM sprawl?
So when I say we have a Jenkins job that can do Terraform for us,
Yeah.
and then that Terraform, behind the scenes what's happening is every team has their own subnet, and one of the parameters that we take in the job is what's your subnet, and we spin their instances there.
So you're sort of with your scripts are managing the separation between
Yes.
the groups. You're creating sort of some kind of a barriers between them.
Yeah, because
Managing how many VMs each group is allowed, or?
every team has a different subnet. So right now we have approximately 130 to 140 Jenkins instances running for the whole.
On how many VMs?
Oh, that's EC2 instances. So that's I would say, it's 1-to-1 right now. So it's we run, every Jenkins instance runs on a EC2 instance.
So you're not taking advantage of multiple.
Well, that's right. So that we started with that, but that was when we were running stuff on VM, and then we migrated to EC2. So our next level is how do we do the orchestration part of it? How do we make sure that we can run multiple containers on a given EC2? But that's coming. That's one of the things in the next roadmap. We are going to do that.
Are you just running, is it just one Jenkins instance for them?
What was that again?
Is it just one instance of Jenkins
For
each team?
Oh, you can have 10. I don't pay the bill.
Are you using Vagrant to roll the VMs?
We have Vagrant in a different set of environment, which is our development environment. So we have a Vagrant setup there too. Yeah.
All right, good. Oh,
Oh no.
no, okay, well. No?
No, he's giving thumbs up.
Okay.